Imagine an artificial intelligence that doesn't just calculate things, but actually deduces, piecing together clues to solve a complex puzzle, just like a master detective. So, let's get right into it. At its heart, whenever an AI is trying to solve a problem, it's basically acting like a detective. You see, it has this mountain of evidence, what we call its knowledge base, and it needs to find that one logical path that leads to the right answer. That's the big idea we're going to break down right now. And the challenge here is huge. Just think about it. An AI has access to this massive ocean of facts and rules. If it just starts looking everywhere at once, it's going to get lost in a sea of possibilities that have absolutely nothing to do with the actual problem. The real trick is to reason efficiently, to know how to look for the answer. So, this brings us to the AI's big dilemma. How in the world does it navigate this ocean of information? Well, it all comes down to the strategy it uses to connect the dots. The part of the AI that's doing all this detective work is called the inference engine. You can totally think of it as the AI's brain. It's the engine that applies logic to the facts it knows, which lets it infer new facts and, ultimately solve the case. Now here's where it gets really interesting. These inference engines have two main detective styles. The first one is data-driven. This is like a detective who shows up at a crime scene, gathers every single piece of evidence they can find, and then just sees what story it tells. The other style is goal-driven. This detective already has a prime suspect in mind and works backward trying to find the proof for their theory. So let's take a closer look at that first style, the data-driven detective. In the world of AI, this method is called forward chaining, and it's all about following the facts wherever they might lead. This one simple question perfectly sums up forward chaining. The AI looks at all the facts it has on hand, and it's constantly asking itself, okay, given everything I know right now, what new conclusions can I draw? What can happen next? So here's how it works, step by step. First, the AI gathers up all the initial facts, all the evidence from the crime scene. Then it starts applying its rules to those facts to figure out new things. These new facts, they just get added to the pile of evidence, and it just repeats this cycle over and over, building this ever-expanding web of knowledge until it either stumbles upon the goal or has chased down every single possible lead. So what's the big takeaway here? Well, the great strength of forward chaining is that it is incredibly thorough. It will find everything that can be concluded from the starting data. But its weakness is really just the flip side of that. It often does a ton of work that is completely irrelevant to the actual goal. This makes it perfect for situations where you want to explore all possible outcomes, like in planning or monitoring systems. All right, let's move on to the other detective style. This is the goal-driven approach, and it's known as backward chaining. Instead of starting with data, this one starts with a question. And that's the key idea right there. Backward chaining takes the ultimate goal, the thing it wants to prove, and it breaks it down into smaller, more manageable sub-goals. It basically says, okay, to prove A, I first need to prove B and C, and then it goes off and tries to prove B and then C. Let's use a classic AI example to make this really concrete. Our goal is to prove the hypothesis, West is the criminal. Now, a forward-chaining system might start by looking at millions of facts about everyone, but a backward-chaining system, it only cares about West. And this diagram just illustrates the process perfectly. Right at the top, we've got our main goal. Prove that West is a criminal. The AI knows a rule. To be a criminal, you have to be American, have a weapon, sell it to a hostile nation, and that nation has to be an enemy. So the main goal gets broken down into these 4 sub-goals. The AI then tackles them one by one. Is West an American? It checks its knowledge base. Yep. Does he have a weapon? Well, to prove that, it needs to find a missile that West owns. And it keeps going down the tree like this. It only looks for facts that are directly relevant to proving its current sub-goal. It's incredibly efficient.
So there we have it, our 2 detectives with 2 very different ways of working. Let's put them side by side and really see the whole picture.
This table lays it all out pretty clearly. Forward chaining starts with facts and moves forward. Backward chaining starts with a goal and works backward. Forward chaining is your go-to when you don't really know what you're looking for and you just want to see what's possible. But backward chaining, that's the champion when you have a very specific question you need to answer, like, is this thing true or false? So when you boil it all down, the choice between these 2 methods really depends on one simple question. Are you exploring what's possible, or are you trying to prove something specific? The right tool always depends on the mystery you're trying to solve.
And this isn't just some abstract idea, right? This stuff is everywhere. Think about a medical diagnostic tool. You type in your symptoms, that's the goal, and it works backward to suggest what might be wrong. That's backward chaining. Now think of an AI in a strategy game planning its next 5 moves. It's looking at the board right now and exploring all possible futures. That's forward chaining. This logic is running under the hood of things we use all the time.
So we've explored how an AI can logically reason its way to an answer. But it kind of raises a deeper question, doesn't it? I mean, following a set of rules, no matter how complicated, is one thing. But what will it take for an AI to move beyond pure logic and actually understand the world it's reasoning about?
That's a puzzle for another day. But for now, you understand the 2 fundamental ways an AI plays detective. If you want to investigate a little further, be sure to check out the resources we've linked in the description below. Thanks for watching.